Let's talk about the data lifecycle. A key concept in data engineering is the data lifecycle. To start, we really need to understand what data actually is. Data is essentially a tangible information object that describes a real-world event. It could be an observation, a measurement, something recorded about the world around us. The icons here represent the idea that data comes from real-world sources. It could be reading from a sensor, an event logged in a system, or notes on something we've observed or something else among many possibilities. How do we get from initial collection of data to turning it into something useful? This is where the data lifecycle comes into play. It's the journey of data from the moment it's captured until it's used to make an impact. We can conceptualize this journey as the data lifecycle, and those steps are what we're going to review in this section. As a heads up for the exam, it's important to be familiar with each step in this lifecycle, the GCP services associated with each of the steps, and how they kind of all connect together. Each of these stages involves a different set of tools and processes, but they all work towards the same goal, which is making data useful and valuable. Let's explore the steps of the data lifecycle, from how data is collected to how it eventually creates value. We start with ingest, represented by the funnel icon. This is where we pull in raw data from multiple sources, such as devices, application logs, or on-prem systems. The data can come in as real-time streams or in batches, and in this phase we might also perform some initial validation and filtering to ensure data quality. Once the data is ingested, it moves on to the storage phase. Here, data is saved in databases or object stores, ensuring it is reliable and accessible for future use. The data may be structured or unstructured depending on its nature, and we'll go over the differences between those later. The key here is to keep the data organized and ready for subsequent processing. Next, we have the process step, represented by the gears icon. During this phase, the data is cleaned, normalized, and enriched to prepare it for analysis. The goal is to bring consistency and quality to the data, transforming it from raw form into a usable state that is ready for insights. And so once the data is processed, we move on to analyze, shown here by the chart icon. This step is where we explore and visualize the data, apply machine learning models, generate meaningful insights. These insights can help us understand patterns, trends, and the story that the data is telling. After analyzing the data, we enter the extract value phase, represented by the light bulb icon. This is where the data insights we gleaned earlier are put to use. We take action, we inform business decisions, we share insights with stakeholders to drive value. It's in this phase that the business truly benefits from all the data-driven efforts. And then finally, let's talk about governance, which is depicted at the center of the lifecycle with a shield icon. Governance is not a distinct phase, but it is instead a concept that influences every step of the data lifecycle. It ensures privacy, compliance, data quality, and security across all phases, providing a framework to use data responsibly and ethically. It's why we have a circle around governance. It's central, and it affects every aspect of the life cycle, from ingestion to value extraction. Remember, the data life cycle isn't always linear, though. It's often iterative. Insights extracted in one phase may inform how we handle data in earlier steps, making this continuous and evolving. Sometimes also the data is processed a bit before it's actually stored. So this is a framework, but don't take it as a strict linear approach. Governance meanwhile, is what keeps everything aligned, ensuring that we're using data effectively and responsibly. Let's talk a bit more about the first phase of the data lifecycle, ingest, and the GCP services that correspond to it. GCP provides multiple services to help manage this phase effectively, and they each have unique capabilities depending on the data type and the requirements. Cloud PubSub is often used to handle real-time streaming data. It's ideal for use cases where events are continuously generated, such as user interactions on a website or application. PubSub allows us to capture these events as they happen and immediately make them available for further processing. Next, we have Cloud Dataflow. This service can be used to ingest data either in real time or in batch mode. It's particularly useful for building ETL pipelines where the data needs to be collected, transformed, and moved to storage or analysis. For IoT use cases, we have a Cloud IoT Core, which is specialized for ingesting data from IoT devices like sensors or connected devices. This allows organizations to collect telemetry data from the edge and process it centrally. Another major aspect of ingestion involves application logs. So GCP's cloud logging service helps in collecting logs from applications like App Engine, Cloud Run, and others. So this could be considered a part of data ingestion as well, actually. These logs provide insights into system behavior, application errors, performance. They're critical for operational monitoring and analysis. Cloud storage is often used for batch ingestion of files or uploads. It serves as an entry point for large data sets that need to be uploaded and stored securely, whether it's batch logs, historical data, structured files that you don't want to put in a database. Cloud storage helps to ensure that the data is reliable and readily available. It's especially used for unstructured data, though. And really you could say the same about other databases as well. Uploading data directly to those databases instead of using a managed ingestion service or streaming ingestion service. So this isn't by no means an exhaustive list, but it's some examples. And in addition to these core services, there are various transfer services. So Transfer Appliance is a hardware solution for securely moving large volumes of data to the cloud, specifically cloud storage. Storage Transfer Service helps in automating the movement of data from on-prem or other cloud environments to cloud storage. And BigQuery Data Transfer Service automates the ingestion of data from external sources directly into BigQuery. Together, these services provide a comprehensive set of tools for getting data into your system, whether it's streaming in real time, migrating from on-prem, or transferring logs and historical data. Ingestion is foundational as it allows you to prepare the data for further processing and get it where it needs to go. And again, this is not an exhaustive list. There are multiple ways to approach ingestion, but these are just the main services that you should be thinking about or aware of for the exam when it comes to that ingestion phase. Now let's move to the store phase of the data lifecycle. This is where we place our ingested data in the right locations, making sure it's both reliable and accessible for processing and analysis later on. GCP offers several services to help with storing data, each with unique capabilities for different types of data and use cases. Cloud storage is our versatile object storage service that is great for storing unstructured data, such as backups, images, any kind of text data, any kind of file. It's highly reliable, making it a great choice for long-term storage. Next, we have BigQuery, which is a serverless data warehouse used to store large volumes of structured data. BigQuery is optimized for analytics workloads, allowing us to perform high-speed queries over massive data sets. For more specific NoSQL wide column storage, Cloud Bigtable is suitable. It's designed for storing large-scale time series or IoT data. Another key service is memory store. It's a fully managed in-memory data store that offers low latency access for caching and session management. It's helpful for optimizing data storage performance by storing frequently accessed data. And Cloud SQL provides managed relational database services for structured transactional data especially. Then there's Cloud Spanner, which combines the benefits of relational databases with scalability, making it ideal for critical applications that need high availability and strong consistency, especially globally. And then for highly structured data, Firestore is a fully managed document database that provides real-time data synchronization, making it great for application data and user data. All of these services provide different ways to ensure that our data is stored in the right format with the right performance and characteristics, and that it's accessible for the next stage of our life cycle, whether we need it for real-time analysis or long-term retention. So we're going to go into each of these services in more detail later in the course, but I'm just showing you which of these services correspond to each step of the life cycle that we just talked about. Now the process stage. In the process stage, various GCP services work together to transform, clean, and enrich data, and this makes it ready for value extraction or analytics. Dataproc is a managed Hadoop, Spark, and Hive service that enables large-scale data processing through distributed computing. It's particularly well suited for ETL processes. We'll go over what ETL means in more detail later, that require significant compute resources and can efficiently process both structured and unstructured data. BigQuery contributes to the processing phase by allowing users to run transformations on data directly within the warehouse using SQL. It can be used to perform operations like aggregations, joins, data normalization. This helps to prepare the data for analysis without moving it between multiple systems. Cloud Data Fusion is an important tool in this stage, providing a visual interface for building and managing data pipelines. It enables you to create data transformation workflows with minimal coding. So it simplifies the development and orchestration of ETL processes or ELT processes. We also have the data loss prevention API, which helps in identifying, classifying, and protecting sensitive data, such as personal identifiable information or credit card numbers. Dataflow supports both batch and streaming data processes. It is highly versatile, making it ideal for real-time data transformations and large-scale data processing workflows. Dataflow ensures that data is properly cleaned and enriched before moving on to further analysis. And it's basically a managed Apache Beam service. Data Prep is an interactive data preparation tool, as you might guess from the name. And it's used for visually exploring, cleaning, and normalizing data. It allows you to see data changes as they are applied and prepare data without needing to use code. Cloud Functions can be used for event-driven data processing, where lightweight functions are executed in response to specific triggers. This is useful for enriching or transforming data on the fly as part of a larger data processing workflow or microservices workflow. And then we have Cloud Composer, which helps to orchestrate data transformation workflows by automating and scheduling tasks. It integrates well with other GCP services. It's very good for managing dependencies between parts of your workflow as well. So it provides a way to manage complex multi-step data processing pipelines that run consistently and reliably. Again, these are not all of the services that could fit into this stage, but many of them here are the main ones. Now I'm going to discuss the analyze phase, and I'm going to discuss it alongside the extract value phase, because really the extract value phase is what you do in your organization or company once you have analyzed the data. It's not necessarily as much dependent on the services. So the GCP services pertain mainly to conducting the actual analysis here. They play a vital role in deriving the insights and transforming raw data into valuable information that you then make decisions on. You'll notice how several of these services have appeared in earlier stages, which showcases their versatility across the lifecycle. BigQuery is a key service that we've already touched upon during the store and the process stages. Here it serves as a powerful tool for executing SQL queries to analyze large data sets and derive valuable insights quickly and efficiently. Looker helps to transform analyzed data into interactive dashboards and reports. It focuses on making insights more accessible to stakeholders through visualizations, making it easier for users to understand and act upon the results without needing the in-depth technical expertise. Dataproc has previously been used in the process stage for running distributed data processing frameworks like Hadoop and Spark. It's useful in the analyze phase because it enables advanced analytics as well if you want to use it for that. Dataflow has been featured throughout various stages as well. In the analyze phase, it is crucial for real-time data analysis pipelines, enabling the generation of near real-time insights from streaming data and especially for parallel processing. In Cloud Data Prep, previously mentioned in the process stage, it provides a user-friendly interface for transforming and preparing data for analysis. So you can actually also use it for analysis. It helps to ensure that the data used in the analysis is clean. You can also do some, quick analysis of your data set and derive some insights and visualizations from it. Bigtable, which appeared in the store stage as well, is also valuable for analytics in scenarios requiring high throughput, especially low latency and time series applications. Then Vertex AI comes into play in the analyze phase by allowing data teams to apply machine learning models to the data. With Vertex AI Workbench, users can develop models and run analyses using Jupyter Notebooks, which provides an interactive environment for experimentation and exploration of the data. The models trained and deployed via Vertex AI can also be used to add predictive analytics into the analysis process, enabling more sophisticated decision making. So notice the interconnectedness, how services like BigQuery, Dataflow, Dataproc, Vertex AI, they're used across multiple stages and how it underscores their flexibility. Depending on the specific needs of the data lifecycle, these services can adapt, providing a useful toolkit for data engineers and analysts. And it speaks to how the lifecycle is a useful framework, but not necessarily set in stone or unidirectional. After completing the analysis, the next step is to extract value from the insights gained. So this involves interpreting ML predictions or using them to actually automate an update, such as recommending content or products to users, communicating findings to relevant stakeholders, informing strategies, and executing decisions based on the analysis. And that's it for analyze and extract value. This slide is focused on the critical aspect of governance, which, as we said, applies to kind of the entire life cycle and involves maintaining control, compliance, and security over data assets throughout their journey. So we'll walk through the services that help ensure data privacy, compliance, and effective management of data resources. Cloud IAM, or Identity and Access Management, is the cornerstone of managing access to resources in GCP. It ensures that the right individuals have the right access, which helps to enforce least privilege and other best practices, thereby maintaining tight security over data assets. Cloud logging helps organizations to maintain records of activities and events occurring across their GCP environment aiding in monitoring, troubleshooting, and ensuring compliance by providing a clear audit trail. Data catalog helps serve as a metadata management tool. And so this makes data assets easier to discover and understand while also facilitating classification and documentation. So this helps maintain data quality and aids compliance with policies across the organization. Dataplex is instrumental in unifying data governance across data lakes and warehouses. It helps to establish consistent governance policies for all data, enabling automated policy enforcement and improving data quality management. Data loss prevention, or the DLP API, plays a critical role in identifying, classifying, and protecting sensitive data. It's used for de-identifying or redacting sensitive information. So this, as you might expect, helps to meet regulatory requirements as well for privacy and ensuring secure data handling. Virtual Private Cloud, or VPC, is essential for securely networking data and managing the flow of data between services. So this provides an isolated, secure environment for running workloads if you set up a VPC, ensuring that data movement is well controlled. The org policy service allows for centralized governance by defining organization-level constraints and policies, helping to enforce regulatory compliance, standardize practices, maintain data integrity throughout your cloud resources. And then we have Key Management Service, or Cloud KMS. It's crucial for managing encryption keys securely. And this allows organizations to encrypt data at rest and control the lifecycle of encryption keys, adding an extra layer of security for sensitive data. Each of these services addresses a different component of data governance, from access control and metadata management to network isolation and encryption. Working together, they ensure that your data remains secure, compliant, and trustworthy throughout the lifecycle. That's the whole idea behind data governance. The goal of governance is to provide a structured framework to maintain this quality, privacy, and control. And that's critical for an organization's compliance and its operational efficiency. All right, and that's it for this section.